Okay, now we continue. So far so good, but as you see, there is an interesting phenomenon. When A is incremented, it is incremented the size of its element, which the element is an array. So it jumps from here to here. That is A plus 1 and then A plus 2. Now, how can we construct pointers which acts like iron? We want to say this is a pointer which points to what? To an array. I want to say I want to have a pointer to an array, an integer array with 4 elements. Up to this time, we haven't seen this. Don't even think of writing something like integer, pointer p, which says p is pointing to a pointer which points to an integer in the memory. That is not fitting this picture. Where is the 4-dimensional array? Right? I want to have something so that when I dereference later P, it becomes the element, this element. If I increment it by 1 and dereference it, it becomes this array. So, very similar to how I use A, I would like to use P as referring to this element, for example, just as we have analyzed. Please understand my wish exactly. I want to have a declaration over here declare P as a pointer variable, and then after that, when I say P is equal to A, I should be able to get my hands on this one just exactly as I did with A. This shall give me this one. How can I do this? First of all, why shall I do it? Plain reason, I want to send, for example, A down to a function. So what shall the function argument be? I know that when I send it, a pointer to the first element is sent. Okay, but now today we have learned that the first element is not this one, but the whole 4-integer array. I send down such an entity's pointers. And how do I define something compatible with this? I will straight away go and write how it is done. You are defining a pointer. In a definition, putting an asterisk in front of this defines, I'm defining a pointer, I'm defining a pointer. You are defining a pointer to what? Normally, you would say float pointer. I'm defining a pointer variable to a float. This time, it has a strange notation actually. You enclose this in parentheses and you define it as a I know this is something totally new to you. How to read it? First, read in the whatever there is in the parentheses. This says, I'm defining a pointer value. If I would say something like this, I would be saying, I'm defining a pointer to the pointer value. A pointer that points to a pointer that points to what? What is that pointing to? Here I am defining a pointer to what? Now remove this one from the picture. You are left with integer 4. Something new to you. This shall be read as an array with integer elements. Integer elemented array with 4 elements. So P is pointing to an integer array with 4 elements. This is integer array with 4 elements. Exactly. Change this to float. You have floating point array. Each element is floating point, and there are 4 such elements in the array. Now comes something striking. Change this to integer pointer, for example. Then each element contains an integer pointer, so something like this. Here lives an integer, will live an integer, here another, here another. On these ends lives integers. But herein there are pointers. Then you would have something like this, and if P is pointing to it, you would say integer pointer P. I hope you get the you have an inkling of how to do it now. Forget it for the moment. Once more, in the parentheses, we define who is referring. A pointer variable named P is referring to, is holding a pointer to integer array of 4 elements. You read it that way. Strange, but it's like that. It works. This is defining a compatible pointer with A. Now, P is equal to A with work. Will work, and you can do everything with P. Normally, you wouldn't do it, but can you increment P? Can you increment P? Can you do this? P plus plus. Can you do this? Which means P is equal to P plus 1. Can you do this? Yes, you can do this. Don't get carried away. You cannot do this. A is a pointer constant defined by the compiler at the moment you have introduced this. It's a pointer constant. This is a pointer value. A cannot be incremented. You cannot change A's value. You can make it subject to pointer algebra, add something, yeah, okay, but you cannot change the value. P is not so. P is now pointing to here. After this, after something like this, you have changed P to point to this position. We'll not remember anything about A. Shall we do it? No, we don't do it usually, except maybe in string arithmetics, but you can do it, by the way. Except this difference, P will act exactly the same as A would, because it provides you a pointer to an array with 4 elements. All the analysis that we made in the last episode about reaching this element, A1, 2, will exactly work with P1, 2. Because there will be positions where P will provide a value. Here A was a naming of a constant. Here P is a variable that holds the constant. When it gets evaluated, it will provide that value and will do exactly the same pointer algebra which we introduced with A. This declaration can be very well used in function arguments. Let's say we take such a matrix in and do something on it. Some func that will take A in. What I have to do is I write okay, very nice. Then when I call it some func A will send down the A pointers down and it will be compatible. Actually, without much of effort, you could very well write integer P3, 4. This would do exactly the same. It would declare P something like this. What about the tree? The tree will simply be ignored. That is also a peculiarity of C. You cannot define an upper size of the array that you are sending down, because you have to send it to a pointer of its first element. So there is no way to somehow get the size out of it. And this is annoying. Either doing this or equivalently in function argument declaration doing it as P4 does not tell the system anything about the tree, one handicap, but a bigger handicap is when you want to change the size that you may send down. Now, just think of a concrete example where you want to write a function that computes the trace of a square matrix or the determinant of a square matrix, or transpose the matrix, a square matrix. How will you send it down? You need a variable in here. Can I have something like this? And no, not in this language. This must be a constant. So what shall I do? Maybe this would work. I send down a void pointer, just the address information. T. Anything can be assigned to T, so this will work. We'll lose, though, the 4. Therefore, I put a second argument, integer r, and hope that the following line will work. Now comes it, integer p r. Can I do this? Can I do this? This is a pointer declaration, which has in the declaration a variable reference. Unfortunately, despite many compilers accept it, ANSI C rejects this. You cannot do it. Though almost all contemporary C compilers, GCC, the Sans C compiler, all accept it. But if you are very keen on sticking to the ANSI standard, you cannot do this. Sorry for that. Terrible problem, isn't it? You want to send a pointer to the first starting point of the array. You also are ready to send the dimension information, but you cannot create down here a flexible array. Even you cannot mix declaration statements with executive statements. That is also forbidden in C. So what to do? There are nice other tricks to do it. Once more, let's state our problem. We want to send such an array down to a function where this size can vary. And I'm ready to let the system know about this. I want to have something like this working for all ends, and in my present special example I will use A with 4, and it will work. What does it mean to work? I will be able to do key 1, 2 and get my hands on this one. I want to have this nice notation because I'm used to it. Of course, you can construct your own indexing mechanism to a function or to a define. This is always possible, but it is ugly. Get element I of A. Then you have to write something like this. Get element of T1, 2. Yes, you can do this. Even to a simple define statement, you can do it. Actually, you have also to stamp the AND information to the define, then you can do it. Look at the ugliness of this. Look at the beauty of this. Of course you would prefer this one. So this is the poor man's solution to it. For a moment, let's stop all this business over here. Forget about this problem. We will be returning to it. Let's consider a hypothetical structure in the memory constructed. These live at different positions in the memory, and I have an array of pointers that point to these segments. How can I construct something like this? Type-wise, what I need here is a pointer to a position in the memory. Here lives an integer. So this is an integer pointer. So I can do something like this. Just give a name, S. Allocate space for S. In my case, it is something like this. Do it all dynamically. Malloc, why do it all dynamically? Because, as you will see, this tree will become 5, 7, 100, a million. I don't know at a compile time. So malloc n times size of integer pointer. Who cares what pointer it is? All pointers are of the same size. This is just to remind myself of it. So I got the position. Then what I have to do is, for I is equal to 0, I less than n, I plus plus, s I whatever that copying is, or assigning is, I need that. From that moment on, if I want to get my hands on this element, this very element, what do I have to do? I go down to S1, pick from there a pointer, this pointer, and this pointer is pointing to the start of it. I want to go not to the 0th element, to the first, to the index 1, then index 2, and to get my hands on this, I want to do this. But this is nothing else but using 2. Oh, very interesting. To get my hands on any of these elements, I can use this notation. As you see, it's very far from this. Here there is an intermediate pointer array sitting in between. A pointer, an array with elements that are pointers, that are pointing to segments in the memory, all having integers. Interestingly, it is also possible to have, let's say, here 3 elements, here 5 elements, and here 4 elements. Nothing is against that, provided that you know how many elements there are in a segment. Somehow you have to know. But that was not in our case. In our case, we have a contiguous, in Turkish, ardışık, block of integers. Right? How can I make use of this phenomena, this programming style, over here? I want to access this array sent to me to something like this by such a mechanism. Let's do it.